अभी हो गया होगा शायद, हुआ क्या? हाँ ठीक है, इसका मतलब हो गया, वो आएगा। So let's start, and we will do, where is that? Okay, so we'll start, and we'll start easy. We'll start with that the circular interest, and we'll add the question is insert a node in a circular link list in a sorted manner. Okay. So a circular link list is something like this, and we'll add inside it. Okay. You'll be given a head, so you know where it starts. Okay. So how would you start doing this is that you will actually first try to figure out what are the different conditions, right? So the first condition would be that the list is null, right? So the list is null. The second condition would be if there is just one node. So if there is just one node, which means that, let's say, one is there, so it is pointing backwards, right? That's the second. Third would be that the data that you are adding is going to get added at the last. Fourth is going to be if it is going to add it to the first node. And fifth condition is that it's a general condition, you are adding in middle of this. Okay, so these are the conditions, and I think like it is mostly, yeah, you can see it. Okay, so yeah. So let's say 2 and 4. Huh?
One node and first node.
So which one? Number 2 and 4.
So there's only one node in the list, and
That is
insert happens on the first row.
Yeah.
So that
Right. So if there is just one node, let's say 1 is there and it is pointing back. But if this was the list 1, 2, 3, 4, 5, and you try to add 0, so what you would have to do is you would have to create a node 0 and then point it to first, and then the last node you have to point it back to this. So that is the difference between 1 and 1. So it's more of a Like, do you conceptually know that, okay, this is what is happening, like how to insert and stuff like that? It's a bit lengthy program, rather than like if there's a trick in it. So these are 4 or 5 conditions, and you would have to write a code for that. Okay, so we'll start writing a new, oh, I should not, but I'll write it in here. Okay, so we'll start writing a code for the linked list. So we'll write a class. So we'll write a class circular list which has a public and a private. And public has a circular list which is a constructor and a destructor, and private has a structure, list node which has integer data, and list node star next. Okay, and we have a head, so we have a list node star and head, and we have a function of sorted insert, so that is void sorted insert with an integer data. Okay, small class, and if you are asked this question, I would want you to actually write the class. This will waste a little bit of time, and then you'll write the sorted insert. So let's start writing the function sorted insert. I'll erase this. Right. So void circular list colon sorted insert and integer data. Okay, so regardless of anything, we'll just create a node. So we'll create a node, a list node star add is equal to new list node. Okay, add arrow data is equal to data, and add arrow next is equal to add. So we created a node and we pointed it back to itself. Okay, so the conditions were no list, only one, third is insert at end, fourth is insert at start, and fifth is the general condition. Okay, so we'll first try for the first condition, that if there is no list, so we'll check if not m head. In that case, the node is already created. We'll just say m head is equal to add and return. Okay.
So this will keep on building the list in a sorted.
Yes. So basically, we just created a class, and there is a function called sorted insert. So whenever we are inserting any value, we create an instance of this circular list and we add it. So when we come, like first time it comes, there is nothing over there, we just add that data. Okay.
So are we assuming that the list is already sorted?
Yes, so the question is that it is a sorted circular list and you have to do an insert. Okay. So the next condition is we check for the only one condition. So how will we check for that? We will check if m head, arrow next is equal to m head. In this case, there can be two conditions, right? So let's say one was there, and so you would have to figure out which one is bigger, the data is bigger or the m head arrow data is bigger. So what you will do is, this is the head. Let's say this was 0 and it was pointing to itself. What should we do right now? So we have to check the data. Okay. So if data is greater than m head arrow data. So in that case, what should happen? If this data is greater, so which means this is 2, which is greater than this. So we will point 2 to the head, and we'll point the head to the 2, and we are done. We don't have to change the head.
Ascending or descending?
It's ascending right now. I don't know, like I haven't written function over here ascending or descending. We can decide, we can change it. So the homework for you guys would be change this function so that you can do ascending and descending. Okay. So we'll do, what will we do? Head, m head, arrow data, arrow next is equal to add, and add arrow next is equal to m head. Okay. Else what we will do is, actually we will do this regardless, right? We will do this regardless. So we will do m head arrow next is equal to add, and add arrow next is equal to add arrow next is equal to head. And then we will check if the new value has to be updated. So we will check if data is smaller than m head arrow data. In that case, we will change the head. So m head is equal to add, and we return from here. Yes. Okay. So this part is done. So we have done this. We have done this. Right. Okay. Let's say we have to insert at the end or at the start. Right. So I don't know. Let's try from the start. In either case, what will happen is you actually 1, 2, 3, 4, 5. Either you have to insert on the start or you have to insert on the end. We actually have to figure out which one is the last node, right? Because the last node has to be manipulated. So let's assume that you have a function called getLastNode. GetLastNode is just returning the last, or you can actually modify your class and say that there's a head also and there's a tail also. That way you'll actually have a pointer. Okay?
In this case, since it's all sorted, basically the position would be determined upon the data. So last or end, I mean, how would it matter? Because
no, like you know the head is there, right?
yeah.
So head is there. If head is there, then this is the tail. This is the last.
Yeah, I get that. But suppose there was like instead of 2, there was I need to insert something between 2 and 3.
Yeah.
So if I suppose I get 2.5, so 2.5 will be inserted between 2 and 3. So
Okay.
Start and end will not matter.
In that case, it won't matter. That is the general condition. That is the general condition. We'll come back to that. So we'll first figure out these two conditions. Then we'll figure out if we have to insert in the last or the start, and then we'll do the general condition. Okay.
So to get the last and head, either we can have in a class or we can have a function which will return that which one is my head, which one is my last.
You can have that. So like the function that I wrote in that in the program, that has a function called getLastNode. So that returns you the last node. So like for when you are giving an interview, I would recommend you that you will say that, okay, now you have this function, assuming that this function is there, and you code it, and then you will write the other function, right? So that way the the interviewer knows that you are writing small functions which are understandable, and that is always good. Yes, sir? Okay, so I'll erase this part. So let's say we have to insert in the start. So we'll check if data is less than m head arrow data, which means that we have to insert it in the start. Okay. So we'll say a list node star last is equal to get last node. So this gives you the pointer to this one, right? So we get last. Now what we have to do is we have to point the last to the add. Yeah. So we will say last arrow next is equal to add, and add arrow next is equal to m head, and m head is equal to add. Right? Yes. So we took care of this condition. Okay, and then we will actually have these two conditions, code these two conditions, so that you will take care of the last one. Okay, so the last two conditions would be a list node star temp is equal to m head. Okay, so we declare a temp node over here, and then we will say while temp arrow next is not equal to, we have to go through the entire row, is equal to m head. Right? So while this does not reach till the end, what we have to do is we have to compare temp arrow data. If temp arrow next arrow data, you tell me. So we have already checked at this point that the value that is coming is actually not is not going to be inserted over here. So we have to figure out if the new value has to be inserted between these two. So we will compare that if temp is at the head right now, temp arrow next arrow data is bigger, smaller,
Is greater.
It's lower than, like you can do anything, like
is greater than data. So in that case, so this one is greater than the data, then the value has to be inserted over there, right? So if it is greater than the data, what we will do is we will say add arrow next is equal to temp arrow next, right? So the add value, let's say it was 1.5, it was pointing to itself. Now we will start pointing this to the 2, and we will start pointing this to the background. So we will say temp arrow next is equal to add and return. Okay? Yes? Okay. So if it comes out of this loop, then that means that the value that we have to insert is in the last. Right? So what we will do is we will say temp arrow next is equal to add, and add arrow next is equal to head, and we return to this. Yes?
In the while loop, where we are actually moving the temp.
Oh yeah, sorry. Temp is good. Temp is equal to temp arrow next. Okay? Yes? Is that good? So I'll just get some water and we'll start. Okay, so we did the. I think it's a little bit too hot. If you feel that it's too cold, let me know.
You know the thing like if
Yes.
and next equals to add, we are already in the if condition.
Which one?
The second line in the if condition.
This one?
Yeah, and then we are also doing outside the loop.
I didn't get it.
And next equals to add, right?
Yes.
So we are doing over here and then outside the value.
But
We are not. We are returning from here.
Oh, okay.
Yeah. So, like once we are there, like we don't need to go through the entire loop. So we just okay. Okay. So this is more of a tedious question rather than you know, trick question. So we did this question. Where was this question? Sorted insert. Sorted insert. We did this. Okay. So let's do a question. So we'll do this. Let's do which one? Let's do a partition. So there's a question which is in the called a Dutch flag problem. It can be changed into other problems also. So the problem with the Dutch flag, this question can be done in arrays also. So the Dutch flag problem is there are 3 different colors, and let's say it's like this. So one is of this color, and second is of this color, and the third one is of I don't know, this color. Right. So all you have to do is you have to, let's say, make blue color in the start, green in between, and red in the end. That's what you want. Yeah, you have to do the sorting kind of thing. So in the end, like blue will come together, and so the question is sort that there are integers. So let's say the linked list have, right now it's not an array, it's a linked list. But the question can be actually an array question also. I haven't done that solution, but like we will do that. So let's say there's a linked list like this. Okay, so 1, 2, 1, 3, 3, 2. Right? So we have to arrange so that all the 1 comes in the start. So it will be like 1, 2, 1, and 1. And then comes 2. So it becomes 2 and 2. And then comes 3 and null. Okay? So you guys tell me how you would do that.
Do we know how many different values you have to handle?
It's just, for now, it's like 1, 2, 3 only. We will actually.
It once,
Huh?
calculate the number of values, traverse it against and replace the values.
No, you actually do not have to change. You have to manipulate the list. That's what the question is. Because otherwise, it's very, very easy, right? Or let's make the question interesting. Like, let's say, we'll do the interesting question also. So we can say that, let's say the values between 0 and 30 will come in the start, and 30 to 45 will come in the middle, and let's say 45 to 100 will be in the last, right?
Yeah, in a random fashion, right? From 0 to 30, randomly.
Yeah. So in that case, you cannot do count the values, right? So So let's say the list was 20. Start giving me numbers. 25.
You still can.
Huh?
You'll create a new list.
Yeah, a new. I don't want to create a new list. I want to use the same. Okay. So let's stick with the 1, 2, 3 problem, and we'll extend that problem and we'll make it.
Are we trying doing ON or
ON, yes, sure. What other solutions do you want to do? We can.
If it is an N square, then it's not interesting.
If you do n square, it's not interesting. Yes. Yeah, that's not good. And in n square, I think you will actually need to have a lot of
Temp variables.
temp variables and stuff like that. It's not very interesting. The solution is not good. Another solution can be you can actually take a stack or something and put those nodes in a stack and do something like that. So 1, 2, 1, 3, 3, 2, something like that. Right. So think about it for a second, and I wish I had. I wish I had a like printer, so I could print it like I can do that. But I don't want to make mistakes on this board. But yes, so give me the solution, right? Think about it.
So we can, so couple of things. We don't have to use any temp variable. We don't have to create any extra list. So we can switch the numbers. So like we can switch
No.
the data between two.
No.
We cannot do that.
Yeah.
Two nodes.
This numbers are
The
No,
thing is,
like,
like, let's try to make it generic. Yes, you can switch the values, but let's say if the interviewer changed the question and said that it is between 0 and 30, 30, 45, 45 and 90, in that case it won't be.
And also in this problem, it should be in ascending order. Because if what if 2 will start in the first instead of 1, so
Sure.
it can be 2, 2, 1, 1.
Yeah.
It
It
can
can be 3, it can be, you can have a 3, you can have 2.
So the output will be 3, 3.
No, the output will always be 1, 1, count the number of ones,
Okay.
and then it will be 2, and then it will be 3.
Those were colors, correct? Not
Colors,
numbers
yes.
are there, so it doesn't matter for me.
Yeah.
So if those are colors, then it can be anything, right?
Yeah.
3, 3, then 2, 2, then 1, 1. Whichever is starting first, it can be first.
No.
He asked for one specifically.
One specific order.
Okay.
It is one specific order.
So that order is given in another variable, right? What will be the order?
Sure. For now, like the order, you know the order. One will come first, and then 2 will come, and then 3 will come. Okay.
So in that case, I will pick the first one and then
Okay.
start looping for the entire list.
Okay.
So whenever I like, for example, first is 1,
Mm-hmm.
so I will start from, there will be 2 pointers.
Okay.
One pointing to the first one. So just with the logic, I
Okay.
can start with current and then runner.
Start from 1 actually. Sorry, this is starting from 1.
Yeah. Let's say it starts from 3.
And I know that I have an order of 1, 2, 3.
Yes.
So from here I am picking up the first number.
Mm-hmm.
I am matching with all.
Okay.
So even I have a head pointing over here. So I
Okay.
don't need runner. So I can start from here,
Mm-hmm.
compare it, this
Sure.
and next. Okay. Position I can maintain. So I can go to next. It doesn't match. Go to next. So
Let's say I give you a
So I
function.
can swipe this and this.
No, you don't swap.
Like this.
Because you
I don't
can
have
use
to-
temp variable.
You can't swap
So
it.
if the, even if I don't want to swap, then I can reposition it. I can bring one here and switch all the list
Okay.
over here. Like
So let's say you have a function called a move to front and another function move to last. You can actually do it that way. So what will happen is like you navigate through this entire list and you say that okay, if it is 1, then move it to the front.
Right.
If it is 3,
Not front. move to the position.
Move to the
And then
right.
the position will move, keep moving. Not also
Why
head.
do you want to keep moving the position, right?
Because it
You can keep changing your head.
You can keep changing the head, that's what I'm saying.
So I think
Yeah,
what he's
because-
saying is once the second number is picked up, he wants to insert it at a position.
Right.
Okay.
Because if I'm moving head, then
Sure.
how can I switch
Yes.
back to the beginning of the
Yes.
list?
So I tried that
So that's
solution
right.
and I
Okay.
tried to solve that and it actually became a really big thing.
Okay.
I will actually solve because there's too many other questions. I'll try, yes, that is one valid question. Let's say you can say that, okay, I have a function move to front, I have a function move to left. If 1 comes, I'll move that to the front. If 3 comes, I'll move to the back. By the time I reach till the end, like
Right.
it will be like, and then I have to keep a pointer saying that, okay, here is where I ended. Because otherwise, like 3 will come and you will continue to send 3 in the end and it will go in the infinite loop. So you have to stop somewhere. That is one solution. Another solution can be that I take 3 pointers. Okay? So I'll say a list node star before, a list node star after, and I will make it to null. Star before, after, and middle. Okay? I will take a temporary variable, I point it to this one. I will say that, okay, if it is before, then point this to this node, before node. Before is already pointing to null. And then what you do is you move to the next one. If it is 2, move it to middle, and then move to the next one. If it is 1, point this to before, before had already had 1. So let's say before was this, middle was this, and after was everything was pointing to null. Okay. So right now there was nothing. I came over here, 1 is there. I move the pointer to 2 and I take 1. 1 should go in before. So I will point 1 which is pointing to null. Okay. Now 2 is there. I will break the 2's link and I will actually say that 2 is in middle. So I'll put 2 over here. Point it to null. 3
Don't you
comes.
have to move before and
Huh?
don't you have to move before and middle to the last
Why do I have to move?
so that next time when I encounter 1 again, I point it to before.
Yeah, so next time you will see that. So 1, 2, now 1 comes. Now 1 comes, so these 2 got broken and added over here. Now 1 comes, 1 I have to add. So I'll break this loop, temp is over here, and I'll start pointing 1 over here. So now 1 is over here. And before becomes equal to this. Right? Yes, I will. So at the end, like you, just bear with me for 2 minutes and you will understand what is
I'm
happening.
not sure how we are maintaining this earlier one's reference for the next one to point to.
Taking a back of it.
And this is specified if there are 3 types, right?
Yes, we can change it. We can change it to the other one too. So start giving me numbers. So 1, I don't know,
3,
3,
2,
2,
3,
3,
2,
2, and then
1.
1. Okay. Now temp is there. So temp is equal to, temp is pointing over here. Okay, right? Before is B, and I will write before B and middle and after. Okay, and all of them are pointing to null. Okay, now 1 comes, 1 should go in before. So I move temp to here, move this to this, and before links comes over here. So that is what, yes. So now before pointer is 1 and before pointer is pointing over here and this is pointing to null. Okay, now we come 3. 3 is going in after. So 3 comes over here, it points to null and after pointer is this. Then comes 2. 2 comes over here. It points to null, and middle is this one. Then comes 3. So this got broken. 3 points to after. After points to here and that. So, and then 2 will come, and then 1 will come. Okay. So at this point we have three pointers. One is pointing till here. So this is before. 2 is here, 3 is here. Now we have to navigate till we reach this end and add these two. And then we have to go to this one, add this and this, and that will do it. Yes? If we want to change this function to saying that, okay, in the middle there should be 0 to 30 and 30 to 45 and 45 to, I don't know, 60, right? So in that case, what will happen is, if 0 to 30, we'll add it in this. If the number is between this, we add it in this. If the number is between that, we add it in that. So that way, he can actually merge this. And this is the order of n solution.
So if
But
there
these
are,
what
if there is
this
these
is what
combinations, right, then we just take as many pointers
You
actually.
take as many pointers. You want to make it as a template, you can make it as a template and templatize it and do that. But I don't think the interviewer will ask you questions beyond this, because this is I think, yes.
Like most of the times, like when you write a program, they need to say then whether your solution is scalable.
Yes. So yes, your solution is scalable, at least for this thing.
Yes.
At least for this it is scalable, right?
No, but it's not. If I
How?
put one more thing, like I want from 70 to 90
Sure.
to the fourth order.
How would you do it in
Like
your
it-
solution? But anyways, from 70 to 90, we can do it. I will, let me write this solution and I will actually change. I don't have the code in front of me. So once I have the code, I will actually.
But again, it's that simple. We need to add one more
One more pointer.
and that's it.
No, but it
So,
has
but
a
logically, his question is that what if one more comes? Then
Yes,
have to
we
change it.
can do that.
So I will have to change my code, right? I will have to change my code. I will
You
have to
can-
change my condition. So that is not scalable.
You can do that. I will do that. Don't worry. Don't worry. It's okay. So, okay. So let's start writing the code for that. Okay. So void a link this colon Dutch flag problem or something. Okay. So if we'll check the condition, if not m head or not m head arrow next, just return, right? Because there's nothing that you can, there's just one node or there's nothing, you don't have to do anything. Okay, so we'll take 3 nodes, a list node star before is equal to null, and instead making that scalable, actually we will probably have, I'll change that, but we'll probably have an integer
Number of buckets.
And I will actually take an array or an array list or vector of list nodes, and I will actually have everyone for that, and I can scale it that way. I'll change the solution so that it will be scalable to that level. Okay, star node before is equal to null, a list node star mid is equal to null. Before mid and after is equal to null. Yes. Then we need to actually take a temporary node which will actually point to head. A list node star temp is equal to m head. Okay. Now we have to go through the loop and break break the nodes. So we'll do while temp exists. While temp exists, what we will do is we'll check if temp arrow data is equal to 1. Okay. If it is equal to 1, what we are doing is a list node star next is equal to temp arrow next. We actually need to get the next node. Save that pointer. So we get the temp arrow next. Then we will say temp arrow next is equal to before. Okay. Temp arrow next is equal to before, and we'll do temp is equal to temp arrow next. Okay. And we'll do a continue over here. So it goes for the next one. Okay. And then we'll write the same thing for if temp arrow data is equal to 2. We'll do the same thing. Instead of this goes over here, instead of before, it will be middle, and that is it. And there will be a third one for that one. Okay. So we do all of this.
I guess you need to, the temp is equal to temp dot next, you need to make it outside the loop, I guess.
Which one?
Temp is equal to temp dot next.
Temp is equal to temp dot next. Sure, we can do that after. But I'm going to continue over here. You can do that after or
No, but this will not work, correct?
how? Actually, I wrote the code.
Okay.
It works. So I know the continue I wrote because like it was giving a null reference exception when it was going to the last one.
But what is the use of next? So a list node next is equal to
So we
temp
are
arrow.
breaking. Basically, initial list was this, right? 1, 2, 3, 1, right? Temp was here. Now we have, if we break this and add this in another list, we actually need this to traverse through this list, right? So that's why we need temp. Right? So we can go to find the next one. So we have to continue. So what is happening is we basically deconstruct this entire list and add it into a different buckets. And then each bucket we are joining them back. Yes.
But what is still my question was, so
Yeah.
what is the use of next pointer over there? Like
Next
just
pointer is
temp-
saving this one.
But we are not using it anyway, right?
Uh,
Just before temp arrow next is equal to before
Okay.
above that line.
Yeah, so the first line, if,
this one?
the
Yes.
question is, where is next being used?
I don't know. Like if it is not getting used, I just wrote this code like 20 minutes ago.
No, I
so-
thought there might be some.
No. So let me think about it. A is before. Okay. Well, maybe you don't need it. So I'll make change to that code. I just wrote it a few minutes ago. So I was thinking, okay, I have to save the next one. So that's why I took the next one. I didn't think about it that way. So maybe that code will work. I will change that code and we'll see if that works. Okay. But after this, you would have to write code for merging all these things. So you will do while before arrow next exists, before next, and then before arrow next is equal to mid, yeah, and then you have to do this same thing for the middle. So, and you will increase the middle, and then you will do mid arrow next is equal to after, and after will be there, right? Yes. Acceptable solution? Yes. Okay. So we'll change that into the thing that you were telling me, right? So we want to make it as a template or something, and we want integer num buckets.
It should be array, like for example, I have 2, 4 and 6, 3 numbers.
Okay.
So in that case, like we also need to tell like what are the numbers also.
Yes. So I integer arr, which will take an array of integers, which will have the values. Let's say 2, 4, 6, right? So anything which is between 2 and 4 will come in the first bucket. Anything between 4 and 6 will come in the second bucket. Anything before 6, after 6 will come on the third bucket. Yeah? Yes? Is that?
I think this can be homework for everyone.
This can be homework, but this is easy. This is easy.
Yeah,
It's
this
not.
is
What you need to do is you need to take a vector of a linked list star, and then you basically define the number of based on number of buckets, and then you go for a for loop, initialize each one to null, and then you go in a while loop, and while loop you will check that if the number is between these two, figure out here. So you can do that. Yes?
Do we need the first parameter like number? Okay, we can actually.
You don't even need that. Yes. You can do that. Yes. Okay. Did everybody understand the solution? Give me a second. Oh, we forward the
Yeah. If you have a vector, sorting will go for
What?
when it's one. The list. If we sort everything.
If you sort everything, yes, but the sorting is n log n, right?
So, but then it will work like, it will be.
Yes,
fair.
I know.
No, square root.
Yes,
So,
yes. Another thing you can do is you can actually sort the entire list. So once you sort the list, then you can actually do that thing, right? Okay. So there is another question in that book of She Who Shall Not Be Named. This is a stupid question anyways, but like since it is there, and if I am given this question, I will actually not think about the solution because it's really stupid anyways. So the question is 250, 30, 26, 50. Yeah, so the question is that this is a list, and you are given a pointer to a node. So you know that, okay, you are given a pointer to the node, and you know that this node is in the middle of this list, right? It's not the start, it's not the last one. That is what you know. And you have to delete this node without traversing the list or anything. And you have just access to this node. How would you do that?
Answers means
Huh?
what we have for this thing?
You have to delete the 30.
Okay.
You have to delete 30. The thing is, like, if you delete 30, 50 was pointing to 30, so the list will actually go away. So you have
Then have a temporary variable and
No, we cannot have that. So maybe like we just like go to the
Next.
26 next, replace it, and then next.
Yes.
So 26 we out of the memory take, right? It's going to be kind of.
Yes, so what the solution, yes, it's a similar kind of thing. What she is saying that do not delete this, copy this value
Yeah, to the previous one.
to this one. So this is 26, and then delete the next one. Yes, so I will see, like the code is very simple. I don't know, do you guys want me to write the code for this?
No, so we can skip.
You can skip. This is by far the most smartest class that I've ever had. You guys know everything. So, yes, okay. So what was Mr. Martin to do? We completed partition around X. So we can actually, okay. So another question in that same thing is that there is a linked list and you have to partition around a value X. So all the values before X are coming on this side, all the values after X will come on that side. Okay, so we have done a similar question like 2 minutes ago. So let me know a solution. How would you do that? If somebody wants to write the code, and should take you less than 5 minutes. The question is, there's a linked list. Let's say the linked list is like this. So 20, 25, 5, 3, 67, 23, 36. All the values which are above 30 should come in the start. All the values which are after 30 should come in the end. So in this, what will happen? 20 is before 30, then 25, then 5, then 3, and then 23, and then 67, and then 36. Yeah?
So order of I think same was like just to have 2 buckets.
Yes. So yeah, 30 से छोटे जितने हैं, everything comes over here. 30 से बड़े is going over there. So
And those are not individual sorted, right?
They don't have
They don't
have it.
It's simple.
yes. So yes, somebody. So write the code on the board for in less than 5 minutes. You can do it.
I think that can be homework.
That can be homework. Why? The other guy over there, he has an interview. So he wants to have all these code solved. So can you do that in less than 5 minutes? 2 minutes? Link list, colon, partition around X, integer X. Okay, so in partition, how many buckets would we need? Two buckets. Okay, a link. Oh, okay. First we'll check if not m head or not m. My handwriting is becoming really horrible. Arrow next. So if head does not exist and head arrow next does not exist, we just return. Okay. Otherwise, we create 2 buckets. So we'll say a list node star, I don't know, before is equal to null. I did not do that as a homework because you really don't need it. You can just solve it. Okay. Then we will take a temporary variable a list node star temp is equal to m head, right? Yes. Yes. Now you go through the entire loop. So we'll say while temp exists. What do we do? If temp arrow data is less than x, what will we do? We will say temp arrow next is equal to before, and then temp is equal to no
Before equal to temp. No,
yes, before.
First
Now, how
we
will
need
we
to
actually
to actually have a backup.
Yeah, that's why we need a next.
Yes.
That's why we need a next.
You need it above the if.
is equal to temp. Temp arrow next. Huh? Okay. So we have, what we will do is temp arrow next is equal to, temp arrow next is equal to before, and then before is equal to temp. Okay. And temp is equal to next. Yes. And then we continue. Else we will have the same condition, and instead of before it will be after. And we'll continue, and after that we'll write the code that before we'll go to the last and then join it. Yes? So we did the question of partition around X, and then there was another question similar to that. But anyways, so we'll take a 5-minute break, and I will try to solve some questions because I haven't solved some of those, and then we'll do that. Yes.
So basically, recording, you said in the code, right? But recording link is the same for me. How do you record?
I will send you.
Do you have like class size?
Yes. Okay. I haven't organized it well, but I will send you. सिल्क में वो